Hey geometers, welcome back to another video lesson with Mr. Forster. Today we'll be looking at our second lesson in Unit 4. We'll be going over what it means to have congruent figures and this thing called CPCTC, which I'll explain further here in a few moments. Your homework is going to be the CAMI assignment that is titled the Unit 4 Lesson 2 homework, which should be linked into the post on Google Classroom where you found the video and the notes for today. Diving into our first concept, going over some of our vocabulary, we have this thing called congruent polygons. And we've mentioned in the past that our way to describe congruent is that the two figures or two objects are measurably the same in every way. Another way to confirm that two figures or polygons are in fact congruent is if they can be mapped onto one another by performing a sequence of or a single rigid motion. So if I can use my rigid motions such as a translation or slide, a reflection or a flip of the image, or finally a rotation or spin of the image. If I can use these motions, these rigid motions, to take one figure and land it perfectly on top of, that's what it means to map it onto another one, then I would say that those two figures are congruent. And so we would say a rigid motion maps each part of a figure to the corresponding part of the image. And so we have an example here of these two triangles, triangle JKL and SRT. And the first question is, what rigid motion could you use to map one of these triangles on top of the other? The rigid motion that we would use would be a rotation of 180 degrees. So you could rotate JKL by 180 and it would land on SRT. Or you could rotate SRT 180 and it would land on JKL. And then another skill that we'll be looking at is this idea of writing what is called a congruence statement. So a congruence statement is exactly that. It's a mathematical statement or a mathematical sentence that says that two things are congruent. So a congruent statement can be of angles. And so we'll look at the different angles that map to each other. So for example, our first arc here, L, and our first arc here, R, you notice they each have one arc on them. So we would say that angles L and R are congruent. And so that's what this statement says. Angle L is congruent to angle R. The next one here, we have two arcs on J. We also have two arcs on T. So the next one we might say is that angle J is congruent to angle T. And then finally, K and S each have three respective arcs. So we can say that angle K is congruent to angle S. Angles are not the only attribute of triangles that we can measure though. We can also measure their side lengths. So we'll look at their sides. And here we see a series of these dashes or tick marks. So you see a single tick mark or a single dash on side JK as well as side ST here. And so I can say that JK is congruent to TS or ST. Where I see two of these dashes is on LK and RS. So I could say that side KL or LK, that would be the same segment, is congruent to side SR or segment SR. And then finally, where I see the three dashes is on this JL and this RT here. And so again, I can say that JL or LJ is congruent to segment RT or segment TR at that point. Here's where the order will matter, is when I write a congruent statement for the entire figure. And so what I want to make sure that I do is I want to make sure that I write them in terms of corresponding parts lining up. So for example, wherever L is for our angle within the sequence of JKL, R should be in the same position because that's the same angle as L. So if I'm writing it for the entire triangle, then we use a triangle symbol. And so if we say triangle JKL, J has the two arcs. And so JKL is congruent to TSR. So again, J has the two arcs. T also has the two arcs. K has the three arcs. S also has the three arcs, so they're both in the second position in our description of the triangles. And then finally, L and R each have the single arc, so they would be in the third position of those two statements, or those two descriptions of the triangle. When we get to the congruent statement of a figure, this is where the order of this statement is going to matter. For the angles, because we're only using a single letter and lining them up, well, there's no order that takes place. For segments, because we're talking about lengths of a segment, the length from J to K and the length from K to J, that would be the same distance. But once I start to add in the fact that I have 3 sets of angles plus 3 sets of sides. Now the order does matter for this one. So I know I keep harping on this, but this is really important that when we get to congruent statements for polygons, order does matter. We're going to look at this thing again. I mentioned it's called CPCTC. And so we have this thing where if I know that 2 triangles are congruent, so if I know that I have congruent triangles, that's this part right here, congruent triangles, then I can make conclusions about the remaining corresponding parts. So what that means is the corresponding parts, which is this guy right here, will also be congruent. So corresponding parts are congruent if I have congruent triangles. So if I know the triangles are congruent, then I can say that all of their corresponding parts, the parts that would line up, would also be congruent. And again, you could swap out the word triangles with figures here, or polygons. This is just kind of a catchy phrase, CPCTC. We'll use it a lot in class, but that is what this means. All right, here we have a few figures in our diagram. It tells us some information here. One of the first things it tells us is that in this diagram, the 2 figures, D, E, F, G, which is this figure here, is congruent to SPQR, which is this figure right there. So we have these 2 figures, and we know that they are congruent. One of the features of congruent figures is their corresponding parts will also be congruent. So if we have 2 figures and we know that they are congruent, we can use this fact to help us solve for some of these values. If we're looking for the value of x, so we're looking for the value of x, I see that I have an x as part of this QR. And so if I look at where QR is right there. And so QR is going to be congruent to FG. So FG is right here. The order again does matter in how these are written, so the order is important. So FG and QR are going to be congruent, which means they're equal to one another. So I can set this up for part A as 2x minus 4 is equal to 12. Adding 4 to both sides, I will get that 2x is equal to 16. Divided by 2, I get that x is equal to 8. So I have now solved for the value of x. Part A is done. The next thing is I want to find out, okay, where do I see y in this particular setup? And I see y right over here in this 6y plus x, and that's going to be right here at angle Q. So that's this angle right here. And Q is right here in SPQR, so it's going to correspond to angle F, which is in the same spots in that 3rd position. So DEF is in the 3rd spot, SPQ is also in the 3rd spot. So again, the order on these statements, these congruent statements matter. So F and Q are going to be the 2 congruent angles. And I know that F here is 68 degrees. So for part B, I can set this up as 6y plus x is equal to 68. And because I've found the value of x being 8, I can use substitution and substitute the value of x in here. So I have 6y plus 8 is equal to 68. From here, I can subtract 8 from both sides, which gives me 6y is equal to 60. Divided by 6 leaves me with y is equal to 10. And then when it says to identify all pairs of the congruent corresponding parts, I'll walk through the angles. So again, the order and the position in which we find them is important. So D is going to be congruent to S for the angles. So we'll do the angles here. So we would say that angle D is congruent to angle S. Next on our list, we have E and P. So we would say angle E is congruent to angle P. Following along, we've already used this fact that angle F is congruent to angle Q. Next, we can say that angle G is congruent to angle R. So those are all my angles. We have 4 angles in the 2 figures, so the angles are taken care of. Next, we want to use our side lengths. So I'm going to slide over just a little bit, give myself some space. For our sides, which we'll do in blue here, DE is going to be one of my sides, so DE. It'll be congruent to SP, so the first and second here. So we can say that DE is congruent to SP. I can then go to EF is congruent to PQ. Next, I can use FG as congruent to QR. And finally, if I kind of wrap around, I have GD is congruent to RS. So again, GD and RS would be my two congruent pieces that I don't have yet. So GD is congruent to RS. So those will be all four of my side lengths taken care of. And now I have all of my congruent angles, all of my congruent corresponding sides, and all of the parts are accounted for. Something that can be very powerful or very helpful when we're looking at some of these congruence ideas with triangles specifically is this thing called the third angles theorem. And so in our first lesson and in your homework, we looked at the reasoning or the idea that all triangles on the plane have their interior angle sums that add up to 180 degrees. So all three angles inside of a triangle will be 180. And so based on this, we can use the idea that if I know two of the angles are congruent in one triangle to the two angles of another triangle, then I can conclude that the third angle or the third pair of angles must also be congruent. So I can then say, okay, I must have that in this case, these must also be congruent. And the reason for that is because they have to add up to that 180. So if I know that A and D are congruent, and that B and E are congruent for those angles in this particular figure, then the conclusion would be that angle C is congruent to angle F, which I have marked in purple above. Here we'll look at an example of applying this concept within a proof, and so have it set up in how we would do our which one doesn't belong. Again, we have our claims on the left, and then the reason that we're making that claim, our warrant or our justification is going to go on the right, and this is common of this idea of a two-column proof. So as we typically do with these, our first thing that we're going to state will be the given statement. It's not always the case, but more often than not, that's what we will do. Our goal is to eventually prove that triangle ACD is congruent to triangle CAB. So I want to establish anything that I can to show that all of the corresponding parts are congruent, because that only happens when I have congruent triangles. That would be the definition of two congruent triangles, of having everything be measurably the same, all the angles and all the sides. My second step, I notice that I have two angles. I have angle up here is congruent to this angle down here. I have two arcs on these two respective angles. So based on our third angles theorem, we could make the claim that the angle at D is congruent to the angle at B. So I'll draw my three arcs on each of those. The next thing that I notice is that they share this side AC here. This is a shared side here. And so it seems a bit redundant to have to say this, but we're going to use the fact that this side is shared to say that it's the same length as itself. If you remember, this is called the reflexive property. I also like to call it the most redundant property, or if you want to have some fun with this, you can call it the no-duh property for our class to say that one thing is congruent to itself. So we can have some fun with that. It's probably the silliest thing that we have to state, or that is widely accepted as something that has to be stated in our triangle proofs. But whenever we see that shared side idea, we're going to use this reflexive property, or again, the no-duh property that we can use for our class. And so finally, I've established that all of the side lengths of each of the triangles is congruent. I have three pairs of side lengths. I have three pairs of angles that are congruent. And so this is, by definition, a pair of congruent triangles, because every way that we can measure these two triangles is identical. Here we have a few more ways that we can go about using some information to establish new values or solve for different values within a pair of triangles. So a couple of things before we dive into what exactly the measure of angle DCN is. I notice that here I have a pair of vertical angles, which means that these two angles will be congruent to one another. I also have the idea that I'm already told that I have 68 degrees here at angle S, and I see that angle D is the same. So that means that this is also going to be 68 degrees. And I have one pair of angles. I have two pair of angles that are congruent, which leads me to believe that the third pair must also be congruent. So that would be angles R and angle C. And since R is 75, it seems reasonable to me that I would say that this is also 75 degrees. which it is. And then it says what additional information would be needed or is needed to conclude that the two triangles in their entirety are congruent. Well, I have all of the angles taken care of, and I have a single pair of sides. So the things that I would need is I would need to establish a few more side lengths. Namely, I would need to know that this side DC is congruent to this side RS. I don't know that yet. That's something that I would need. So again, what information is needed? The other thing that I would need would be that side DN is congruent to side SN. So those would be the two things that I need. So DN and SN and DC and SR. I don't have those things, but again, it's asking what information is needed in order to claim that the two triangles are in fact congruent. All right, that concludes our video lesson for today. Again, your homework assignment is the Kami assignment that is attached to the post where you found the video and the notes for today. We'll take a look at it tomorrow if you have any further questions. The homework, I believe, is a single page and is fairly short. There are some challenging problems on there on purpose to kind of push your thinking, and so I don't want you to stress too much if there are one or two on there that you are not super confident on. I did make this homework a little bit more challenging, so please keep that in mind. And we'll look at some of those things together at the beginning of class on Wednesday. So hope you're doing well, and I hope you are having a strong finish to your first quarter, and I look forward to seeing you in class.